Hi, everyone. Welcome back from the very, very brief break that we gave you. We're going to start with our first session of lightning talks. And just as a bit of logistical information for the next couple days, the Zoom that you're in right now is the same Zoom that you'll use tomorrow and Thursday to access the lightning talk sessions. So if you're here now, that's where you need to be tomorrow and Thursday. Like Josh mentioned, these are recorded, but most of the folks who are presenting via recording are also here in the meeting. So we'll plan to have a Q&A session at the end. If you have questions, you can save them for the end and feel free to unmute. You can also post them in the chat, and Josh and Glenn and I will do our best to try to manage those and ask them verbally at the end of the session. But I will let Josh, who's doing the technical work on the back, get set up. The first lightning talk we have today is Applying Computer Vision to Legacy Digitization at the New York Public Library, and that is from Eric Schaus at NYPL.
My name is Eric Schaus, and I'm the Assistant Director of Digital.
Sorry, folks, give me 1 second. It was working when I tested it. Let me try again.
Hello.
There it was. Can you hear
Hello. My name is Eric Schaus, and I'm the Assistant Director of Digital Collections at the New York Public Library. Today I'm going to tell you about a project in part inspired by presentations at this summer's IIIF conference in Naples, as well as all the various IIIF compliant applications that have been built to utilize, share, and activate images. Today I'll be focusing primarily on digitized maps as a starting point. The library has retired its crowdsourced georectification application, so I reached out to the AllMaps folks about integrating our existing data. The image request URIs we provided alongside the geodata revealed that over 4,500 images from digitized maps were missing a web-ready, high-resolution cropped derivative. Instead, for those images, we only had a cropped derivative at 760 pixels on the long edge, and the uncropped preservation TIFF file with color targets and extra borders. This means that IIIF integration for those maps would be far more manual than we would want, and NYPL's digital collections isn't offering a deep zoom option for cartographic materials where research usability often hinges on the ability to view small details and place names. This has been a known issue for many years, and a former colleague mentioned seeing an image matching demo that could solve this problem probably a decade ago. However, as NYPL digs into the promise of third-party apps like AllMaps and looks ahead to a global rollout of our IIIF image server, which is Cantaloupe, it's time to audit our digitization history and find tools to address issues like this. The reasons why we chose not to save high-resolution web-ready and hand-cropped images are lost time, but undoubtedly were linked with storage cost considerations that have become less and less burdensome in the ensuing decade. Regardless, the sets of files that were saved have varied over time, and there's a cutoff point beyond which we simply don't have the files we'd most want to share with our IIIF server. In all, a little over 1 million high-resolution still image captures, out of about 2.8 million total in our repository, have been identified that are missing a web-ready high-resolution derivative. The sheer scale and diversity of NYPL's digital collections, combined with resource restraints, necessitates a novel approach. In other words, it would be inhumane and impractical to recrop all 1 million images by hand. So the goal of this project is to put the computers to work instead. After poking around various GitHub repos, and with Bert's help, thanks Bert, I settled on 2 algorithms for feature detection and predictive matching, SIFT and FLAN, to compare the uncropped files to the low-res cropped derivatives in order to find where the cropped boundary might be automatically detected to create a new high-resolution JP2. SIFT stands for Scale Invariant Feature Transform. It's the scale invariant component that's most important here. FLAN is fast library for approximate nearest neighbors, which can quickly match detected features between 2 images, and is based on the k-nearest neighbors supervised learning algorithm. Initial tests were quite successful right out of the box, but operationalizing the script, which I wrote in Python, and scaling it up for hundreds of thousands of images meant encountering and picking off problems one by one. The first issue was converting large color spaces from the preservation TIFF into web-native sRGB color spaces and maintaining the correct color space throughout the pipeline. Finding the correct rotation of where the crop should be relative to the boundaries of the uncropped TIFF proved challenging in several ways, but drawing the predicted rectangle boundary for the crop and circles where the predicted new corners should be on test files helped identify this disparity. Some derivatives were oriented differently than their preservation originals. I found that some crops extended beyond the original image, and this requires expanding the canvas of the preservation file before applying a new crop. In the end, it became necessary to rotate the pixels of an image around a center point before painting them onto a new canvas. Some images happen to have the exact same cropped boundary at a different scale, which caused errors, and I still see the script produce an image or two out of every 1,000 that looks like meringue pie, because not enough features are detected. I filtered these out by creating a scaled-down version of the new file to compare with the old cropped derivative pixel by pixel using root mean squared error. 8% is high, but I've tracked that down to lens correction being applied to one version and not the other. There's always something. In all, it's a functioning program that does still need a little bit of hand-holding and manual review of the files to look for egregious errors, but those are luckily few and far between. I've been able to convert about 100,000 of the 1 million missing images, including all 4,500 map images. And looking ahead, the challenges are to completely refine the pipeline and filter out errors on the go. Not all of the remaining 1 million images actually need this treatment, because some of them aren't even online for various reasons like copyright or because they're part of an abandoned project or what have you. So work remains to be done to chunk this out a little bit. I'm also interested in experimenting with clustering techniques to identify visual groups that clearly would benefit from a new high-res derivative. I've also experimented with a new algorithm that was announced in the paper this past summer called light glue, which seems to be the state of the art and quite speedy. All that said, it's a funny problem and really falls into the category of things that an institution like NYPL often never gets around to solving. However, to me the benefits are quite clear. Not only will our digital collections be that much more IIIF compliant, and with an increased ability to interact with third-party IIIF compliant applications, but visitors to digital collections itself benefit by being able to see our collections in all their high-resolution glory. And proving that this is possible means that other institutions could potentially benefit from a similar approach, especially those like NYPL that have a 20-plus year history of digitization. Thank you.
Okay, and as I said earlier, if you have questions about any of the lightning talks, please post them in the chat if you don't want to speak at the end. Up next, we have Annocoda, a web app to search images based on their annotations by John Moore at the National Archives, UK.
Hello everyone. Annocoda, a web app to search images based on their annotations. Start with a quick demonstration. So to search annotations, you need to have a manifest and then supply some keywords, but we can use some predefined links here. In this example, we're searching the manifest for the keyword terms women and war. Let's come back with a single result, single image, and single annotation, and we can highlight within the image where that annotation is. If we have a look at another example of searching OCR content from a book called Rustic Walking Routes, looking for the term pinner, let's come back with multiple results. We can swipe through these, the annotations to see where in the image it's found the term pinner. And the code is built using Presentation API 3.0 and the Content Search API 2.0. If you're not familiar with annotations, typically they're embedded within a manifest And the content can also be stored externally in reference from the manifest. For large amounts of annotations, annotation servers such as Miffy could be used. Searching annotations can be done using traditional enterprise products like Elasticsearch and Solr. They're good at doing keyword searching of text. They come with their own APIs, but the approach for IIIF is to standardize what that API should look like so that we can then build solutions into our products and our viewers. I believe there's work for the community to bring more search services online. For Annocoda, I built my own search service called Annotas, and Annotas works by supplying a manifest or collection. We can see now a Hello World style deployment of Annocoda. I'll be using the image from Göttingen 2019, single image, which has a single annotation. In this case, it's a tag. We'll start the annotation service, content search service, using that manifest, and we'll start Annocoda locally. Let's just check that the search service is running, and let's open it in Annocoda. And we've searched the term Brunnen and got back that same image, which has the single annotation, which highlights the same part of the image we saw before. So Annocoda is built using Python and Dash, and Dash allows you to wrap JavaScript components to do traditional client-side web development, but stay in the Python world. And it's built, Annocoda is built using some of the bootstrap components, such as an image carousel slider. The search results that come back are all stored within the client's web browser, so it's a light deployment on the server side. Most of the complexity comes from trying to parse IIIF manifests and collections, handling the fringe cases that come up. IIIF Prezi 3 is a great community product to help with that process, and Annocoda uses it, and Annotas. So moving off from keyword search, semantic search is an interesting option. Traditionally, semantic search is powered by knowledge graphs and relationships between entities, but for scalable generalized search, an LLM, large language model, is an interesting alternative, and I've built a version of Annotas which does exactly that. So it uses an LLM to generate some embeddings, and these embeddings are compared against each other for similarity to then be able to retrieve back the annotations. The easiest way to see that through a demonstration. So if we have a look at this manifest, it is a export from our web archive and has annotation content which we will use to carry out semantic search with. So this manifest is fed into the semantic version of Annotas, and it allows us then to put in natural language searches, in this case show some naval vessels, and the results are very promising for this example. And what's really interesting about the results is that if we take a look at how it's found the annotation, there's no mention of naval vessel in this description. So it's particularly good at handling where keyword search would fail in this case. And thank you very much. I look forward to your questions.
Okay, up next is IIIF and GIS, a two-way bridge from Grzegorz Myrda and Maria Fronczak at the Institute of History at the Polish Academy of Sciences.
Hi everyone, we are from the Institute of History of the Polish Academy of Sciences. Grzegorz Myrda
and Maria Fronczak.
Thank you for having us at this meeting. We are very happy and grateful for the opportunity to present here. Today we want to tell you about our experiments in creating a connection between GIS and IIIF. Where do our needs in this area come from? As we work in the Department of Historical Atlas and we use GIS tools in our daily work, we have strong GIS infrastructure in terms of both client tools and server applications. At the same time, our data sources include, in addition to historical maps, source materials in the form of text containing references to geographical space. As part of our work, we created, among other things, a tool which you can see now, which is used to index selected content from source materials, such as medieval manuscript. So what you see now uses only GIS technology and standards. What is obvious in the case of the small map window may not be so obvious in the case of manuscript view. But please believe me that the images of the manuscript visible on the screen next to the map are visualized using the same GIS technology and standards. This applies to both the raster part and the overlaid text part. As more and more materials are available in the IIIF format, we wanted to have the possibility of using data directly in the IIIF standard, but continuing to use the same end-user GIS tools. Secondly, we wanted to ensure the possibility of sharing our existing resources, or rather services, using IIIF standard. So let's go back to the roots. The basic element of the technology we use is the OGC WMS standard, so Web Map Service. There are many variants of that specification, such as WMS Tilet or XYZ or WMS Time, but the root of all of them is WMS standard. We can notice here that if we remove two phrases from the definition of this standard, we will get a definition that generally also fits the IIIF service. Using a definition of a basic request sent to the server asking for an image, it can be seen that the difference is actually one parameter, coordinate system. The remaining parameters basically correspond to each other, they just have different names. So the question arises, is there a need for two servers to handle such requests, or would one be enough? That's a question that probably cannot be answered easily. Still, we would like to pose it here. And that's why I will give the floor to Maria.
Let me tell you now about building bridges between IIIF and GIS, with the disclaimer that in this presentation we are skipping georeferencing. First, the easier direction from GIS to IIIF, specifically from WMS to the image API. So what this direction gives you? Well, it allows you to reuse all the WMS resources, like this handsome map, in IIIF manifests. Of course, you could reduce this direction to producing and republishing images instead of dealing with WMS layers, but we think it's not very much in the spirit of IIIF, and neither it is in the WMS spirit. What we believe to be more in the IIIF and WMS spirit is the publish once and reuse approach, which means that when the IIIF server here receives a request, it will make its own request over the internet to the WMS server in order to obtain an image. We will present two possible solutions to implement this approach. The first one is a rock-solid solution, to use an existing battle-tested image API server, one that is capable of working with images available over the internet, like Cantaloupe. But this solution has its drawbacks. The WMS server is treated like any old HTTP server, and we are neglecting some possible optimizations. So another solution which we adopted is to write an image API server from scratch, optimizing for the fact that we are using a WMS server. Then the whole construction is perhaps a little bit less stable, but optimized for what we have. So, glossing over the details, Here, the image API server makes an optimized request to the WMS server, and from that, some optimizations follow. And the question to sum up this direction from GIS to IIIF would be the following: if it would be worthwhile to combine both solutions and to prepare an optimized WMS extension for an existing server like Cantaloupe. And now we step onto this slightly risky bridge leading from IIIF to GIS, from the image API to WMS. Why this bridge is worth crossing? It allows you to make any IIIF image available to all the WMS compliant tools, from OpenLayers and Leaflet to QGIS and the like, to our own indexer. And we have a first prototype of a WMS server, which is capable of working with image API servers. It's written from scratch, but it covers basically the mandatory part of the WMS specification. It's more or less implemented like our optimized WMS to IIIF server mentioned before, just the other way around. With this prototype, we can access any IIIF image with any WMS client, like here.
Okay, to sum up. Well, there is a question whether to GIS or not to GIS. And we are aware of the AllMaps approach that is rather not to GIS. As you see, we take a complementary approach relying on GIS because using GIS is natural to us. But also we believe that both standards, IIIF and GIS, do have a lot in common, and those bridges are worth exploring. So right now we have the two prototypes mentioned in both directions, from IIIF to GIS and from GIS to IIIF. And we are very interested in hearing from the community whether bridging IIIF and GIS is of interest to you. If it is, please do contact us. Thank you.
Okay, up next, we have Making Open Source Stories from John White at Cogapp.
Hi everyone, I'm John White, and this is Making Open Source Stories. Just a little bit of background for anyone that isn't already familiar with the project. In 2017, I co-presented at the IIIF conference in the Vatican with my colleague Tristan, and we presented a talk showing various proof of concepts that would leverage annotations and IIIF images to associate bits of what would usually be text with regions of the image to create linear story-like narratives. And after the conference, we published those proof of concepts online as stories. And then afterwards, we created a tool that would make manifests that were compatible with those concepts called Storiiies Editor. So the concepts that we had initially were a basic example with taking the annotation list and the manifest and producing a web page. A speaking example that would use the web speech synthesis API to talk aloud each of the text annotations. A broadcasting example where one client would be able to control many other clients, OpenSeaDragon viewers across the network using WebSockets. And a viewer example, which really came to be the core presentation that we tended to use, which was a previous and next button that changed the active annotation superimposed on the corresponding part of the image. So many people had asked us whether or not we would be open sourcing the project. And it took us a few years, but very recently, a few weeks ago, we open sourced the viewer. And we really wanted to make something that was simple, customizable, and that people could host themselves and could be initialized much like you would do with Myrda or OpenSeaDragon or even a carousel. We wanted to have all of the features that we had in the previous style viewer, but at the same time, we wanted to make some updates. So switching the presentation API up to V3, adopting community tools and conventions, specifically Manifesto and TypeScript. And we wanted to put this code into more people's hands. So it has a very permissive open source license. So I mentioned earlier that we updated to the presentation API v3. So previously on the left, we used to have a reference to an annotation list stored in the other content field in the manifest JSON, and then the annotations would be in the annotation lists in a separate file, and that would contain the content and the region of the image that it refers to. But now we're leaning more towards this example on the right, which is inspired by this link I have underneath to the cookbook, where the annotations are nested directly in the annotations key on the canvas level inside of the manifest. So no need for two files. We are just able to get away with this one file now. And some of the other information that Storiies uses is also stored in the manifest, like summary and required statement. So the tech stack that we have is vanilla TypeScript. We decided very early on not to use a framework for this. We felt like we would maybe default to using React for most things at Cogapp, but we didn't want this to be a barrier, and we felt like having our dependency footprint be as small as possible had a lot more benefits. So no frameworks to be seen. We have vanilla CSS. It's very themable with custom properties. Quite a lot of things could just be styled using those, but the CSS is entirely optional. You could completely replace it or not use it at all. OpenSeaDragon is the viewer that drives Storiies viewer, and it was a very easy choice for us to make at Cogapp. We're very familiar with OpenSeaDragon. It's mature, it's stable. It's not the only choice, but it felt like an easy option to choose that one. And Manifesto, we are using to extract information from the manifest. At Cypress, we have automated end-to-end testing. Something new that we did with that here is we have IIIF level 0 images being intercepted and returning the level 0 images from the fixtures instead of actually hitting the network. So that's pretty cool. And then Vite is used just to bundle the whole thing up. So some future possibilities, some things that we think there are pathways for that we would like to see the direction of Storiies travel. We think that multi-image support would be really good. We'd really like to see multilingual support too. I'd be really interested to know if a web component would be of interest to the community. It can already be installed using npm or included as a script tag, but I think we'll start to see more and more web component sort of instantiations of this kind of package in the future. It would be really good to contribute back into Manifesto, because some of the I referenced the cookbook example that we're sort of using for the annotation structure. That isn't currently fully implemented in Manifesto at the moment, so it'd be good to add some of the work that we've done with that back into Manifesto. And then lastly, I think, someone's bound to ask us at some point whether or not we're going to make an open source version of the editor, and that's definitely something that I would like to look at in the future. So with that, I would like just to say thank you very much. If you have any questions, there's more information on the website linked here. You can get in touch via email, and please have a look at the GitHub repository. We would love to have some more contributions. Thanks.
Great. And up next, we have Machines Reading Maps, Unearthing the Research Potential of Historic Maps from David Wong and Drake Zabriskie of Luna Imaging.
Hi, this is Drake Zabriskie. I'm CEO of Luna Imaging. I want to talk about a project we've been working on for the last year called Machines Reading Maps. This was a collaboration with the Alan Turing Institute, University of Minnesota, Austrian Institute of Technology, and the University of Southern California. It had three components that we worked with. One is the map curator, which is machine learning, and that is what identifies the place names on maps and does the OCR on them. And then Luna for the visualization and returning of results within the Luna tool set. And within that, we also have a tool for editing and viewing the annotations, which is called Annotations. And with that, I'm going to pass this on to David Wong, who's going to give you more information about this.
Hello, everyone. I'm David Wong, a software developer here at Luna Imaging. And it's my pleasure to talk about the latest developments of Luna. In this project, the map creator system generated over 89 million word-based text labels for the David Rumsey map collection, with the map containing the highest count boasting close to 116,000 detected words. Thanks to Luna's existing IIIF infrastructure and our integration efforts, users can now harness this vast amount of data right within Luna. These machine-generated labels are served to the front end as web annotations and IIIF images. And we offer two unique ways to present search results. The first option is what we call masonry view. In this view, each annotation is displayed as an individual IIIF image. The aim of this view is to provide a structured and organized way to scroll through your search result, making it easy to appreciate the details and beauty of these historical maps. The second option, grid view, takes a different approach. It uses drop-ins to identify annotations which provide a visual representation of your search result right on the maps themselves. Rolling over the full image activates a pop-up containing the detected region of the map, matching your search criteria. These clickable IIIF images can take you to the full-size map. It's a fantastic way to search and interact with geographic information. Since the OCR results are word-based, each word is treated as a separate annotation. To make it easier to search for multiple words together in Luna, we implemented spatial search. Typically, spatial search involves finding objects based on geographic coordinates, but in this case, we use image coordinates of the annotations generated by Map Creator. This technique helps us find annotations that are physically close to each other on a map. For example, if we search for just Florida, there are more than 6,000 annotations. However, searching for Florida key specifically returns only about 200 results. When multiple matching annotations are close by, they are dynamically grouped into a single bounding box for a cleaner presentation. To look at the full image, simply click on one of the thumbnail tiles. This action will open the image in the viewer, zoomed in to focus on the selected annotation, which is highlighted by the client. Using Luna as an annotation server and Annotations as a client, we have enabled user to make changes to the machine-generated annotations, which includes both the transcription as well as the bounding polygons. This serves as a crowdsourcing effort to improve accuracy of the transcriptions. A history of changes is maintained for each annotation and is listed in chronological order in the client. Changes are indexed daily, and they are searchable along with the original detected text. Here I'm going to change the polygon and update the text. If the shape of the annotations are updated, it will generate new SVG selector, and the bounding rectangles in masonry view will also reflect these changes. We also offer this powerful feature in advanced search that allows you to do searches based on text on the maps combined with catalog metadata as search criteria. This means you can refine your searches not only by the content within the maps themselves, but also by additional information such as publisher, region, title, subject, type, or dates. For example, if I want to search for Mississippi River, but only from maps dated from 1800 to 1830, it can be done this way. And hit search. Thank you for listening. If you have any feedback, questions, or comments, feel free to reach out to us. Thank you.
Okay, so a big thank you to all our presenters who I believe are all here in the meeting, so we can give them kind of a virtual round of applause. And we have some time now, about 20 minutes for questions. So like I said earlier, if you want to either raise your hand in the chat or unmute and speak up, you can. Otherwise, if you have posted a question in the chat, I will do my best to read them out. And I have one here for John. John, you're here, right? The question is regarding stories. Can one deploy a story in an entirely static website? So JavaScript plus a manifest with annotations and level 0 static images.
Hello, can you hear me? Great.
Yep.
Yes, that's a really interesting question. It's not a use case that I've thought about, so it's that's one of the reasons why I'm excited to hear what people think about this. But yeah, I think that sounds an awful lot like what's happening in our test suite with Cypress at the minute. So I think, yeah, like in theory, that sounds entirely possible as long as you have a valid manifest, and if you have the level 0 images, then there's no reason it shouldn't work. But I haven't tested that.
Yeah, thanks, John. It was my question, and it was your mention of level 0 images in the test suite which sort of triggered me to think like that.
Yeah, I think it should work, but I'll go away and try that and maybe come back to you with that solid answer.
Okay. We also have a question for the machines reading maps folks. Are any of these search functionalities exposed via the IIIF content search API?
Hi, I'm David. The answer is yes, you can search within the map, but you cannot use the content search API to search across different maps.
Fantastic. Thanks, thanks, David.
Other questions? Josh, I think you can jump in.
Hi. Yeah. So this is a question for John Moore about Annocoda, and maybe I missed it. I was trying to not touch my computer so that it wouldn't screw up the video. But I guess my question is: it looks like some really interesting example of using image features as a search potential, and that sparks so many ideas. And you should talk to the artificial intelligence community group because I think they'd love to see that. But I guess my question is. You sort of proved a point that was independent of any metadata or text associated with the image or the title. Have you explored sort of the next step, which I think would be sort of trying to align that with, with metadata or existing text, the headings, whatever that might be? I know that's a huge question, but I just wonder if that's sort of where you're going, or if that's sort of where the proof of concept ends. I also don't know if you're here, so I may have just asked that question to Noah. Oh, you are? Okay.
Yes, all right, I'm here. Initially, it was to search OCR content. That's an area that we've yet to explore in depth, but I think that opened up other interesting directions, and also the sort of exploratory search that you can do if you go beyond keyword searching. So the LLM-based search kind of gave another dimension based on that same OCR content to find things that you weren't particularly good at keywording. But the data just basically came mostly from automated OCR process.
That's great. Thank you. And as Tom said, get in touch with us if you're not already involved with that AIM IIIF group. We'll get you connected to the chairs there.
Okay, let's go to the Luna imaging folks again. Are user annotation revisions moderated, and are they fed back into the source manifests? Is there a limit to how much a user can change the bounding box for a single annotation?
Yeah, hi, this is Drake. The user annotations are not moderated at this point. It's kind of a open forum. You have to be logged in, so you are recognized as far as that goes. So your identity is recorded as you registered, so whatever that means. But because we haven't seen any real issues there, we've just kind of let it be open. And I think we want to kind of make that information available. And we want to maintain that history too. So we're maintaining a history of those annotation changes as it goes. So we'll see what happens as things move forward.
Okay, thank you. And then if we can hop back to John and Stories, Christopher Gilman says that they use them actively in online learning activities with multiple students contributing annotated views. Can Stories be adapted to track names of contributors and include them in the captions?
I think that sounds like a reasonable goal. That's, not to sell it short, but it's Stories in general is deceptively simple. It basically will track the active annotation index, and it will display the information captured in that, which would be the region of the image and the annotation. And it could be expanded to if it was without any modifications, if the contributor was inside of the annotation, it would just work, but you could add another field and sort of get it to pull that out too.
Okay, any other questions from folks? we'll wait just another minute in case people are typing. I'd hate to cut you off mid-sentence. Okay, it seems like we've answered everyone's questions, but if you have one while I'm speaking, please, I will stop talking and ask your question for you. I'd like to thank everyone who submitted a lightning talk today, one for the work of doing it, but also then making the effort to come here and answer questions for everyone. We have 2 more sets of lightning talks that are happening tomorrow at 1:30 p.m. Eastern and 1:30 p.m. Eastern on Thursday. Like I said at the top of the hour, you will use the same Zoom that you used today, and you can refer back to Eventbrite to log in. If you have registered for a workshop tomorrow or Thursday morning, you will have received a separate Zoom link for that. If you have any questions or if you can't make it, please send me an email. I will put that in the chat here. There are lots of folks who weren't able to get into workshops and I'm sure would like to make it if you are unable to. But thanks again, everyone, for joining us today, and we look forward to seeing lots of you tomorrow. Okay. Thanks all.